In the last 50 years, the world's population has roughly doubled, but appetite for meat has increased by a factor of 5, and since 1950 we have depleted around 90% of global fish stocks. This large increase in consumption is due to a growing affluent population, which is set to increase in coming years. A vegetarian diet is estimated to require 1 million litres of water per person per year, whereas a meat-based diet is estimated at 2 million litres. In addition to this, the ineffective conversion of energy means 6 kilograms of plant matter is required for 1 kilogram of meat. This video will discuss the environmental impact of various diets. The production of meat is expected to increase significantly from 229 million tonnes in 2000 to 465 million tonnes by 2050, due to an increasing human population and many developing countries becoming more affluent. Livestock production currently uses 30% of the Earth's entire land surface, mostly for permanent grazing pasture, although 33% of this land is used for livestock feed production. This has caused extensive deforestation, particularly in the tropics. For example, 70% of forests in the Amazon have been cut down and converted into pasture for livestock. Around 2.4 million hectares of forest are cut down every year and converted into pasture, with an additional 0.5 million hectares cut down every year for feed crop production. Along the food chain, meat production accounts for 64% of ammonia, which is a major contributor to acid rain and acidification. It also accounts for 18% of total anthropogenic greenhouse gas emissions, more than all global transport emissions put together. Of this 18%, 36% of greenhouse gas emissions from meat production comes from land use and land use change, 7% from feed production, 25% from animals, 31% from the storage and treatment of manure, and just 1% from the processing and transportation of the final meat product itself. The production of pork requires 10.55 metres squared of land per kilogram of pork, whilst chicken requires 8.65 metres squared per kilogram, and beef has the highest land requirement with 38 metres squared per kilogram. This is largely due to the inefficiency of cows converting ingested energy into meat and a lower number of offspring compared to pigs and chickens. Additionally, 26 megajoules of energy is required to produce 1 kilogram of pork, 22 megajoules to produce 1 kilogram of chicken, whilst 43 megajoules is required for 1 kilogram of beef. In terms of the global warming potential and their carbon dioxide equivalent in emissions, beef has the highest contribution with 23 carbon dioxide equivalents needed to produce just 1 kilogram of beef, whereas 1 kilogram of pork contributes 6.95 carbon dioxide equivalents, and chicken contributes the least with 5.3 kilograms of carbon dioxide equivalent in emissions per 1 kilogram. Over the past 60 years, the booming population, linked with the intensification of fishing practices, has resulted in 90% depletion of global fish stocks. Despite this, fish is still seen as a widespread, affordable and valuable source of protein for a large portion of the world's population. Many industrializing nations have experienced significant economic development over the past 2 decades, resulting in a vast increase in the per capita intake of fish proteins. As a result, fish production for human consumption has been the fastest growing food industry worldwide over the last 20 years. On a global scale, the consumption of fish per person per year in 2005 averaged 23.5 kilograms or 141 million tons collectively, with 1.2 billion people currently depending on fish as their principal source of protein. Growth in this industry is having severely detrimental implications for marine ecosystems. High trophic status marine species characterized by large body size, late maturity, and long lifespans are perceived to be the most vulnerable to overfishing practices. Low trophic level species were originally thought to be more resilient to extensive fishing practices based on their fast growth to maturity and high productivity. However, numerous scientific studies have found that up to twice as many low trophic level species have collapsed compared to large marine species. Even temporary collapses of low trophic level marine species can significantly impact food supply for higher trophic level species within the ecosystem, including larger fish, seabirds, and marine mammals. The industrialization of fishing practices has resulted in the largest trawling net openings being 23,000 meters squared, or the equivalent of 4 football fields, capable of catching 500 tons of fish. Additionally, long-line fishing vessels deploy 1.4 billion hooks a year, each covered with a portion of fish for bait. Non-target species caught by fishing operations are referred to as bycatch. A small proportion of these may be sold, however they are generally considered unusable or unwanted as a result of numerous economic and regulatory factors, and subsequently thrown back into the sea, often dead or dying. Typically, for every 1 kilogram of shrimp caught by trawling vessels, 9 kilograms of other marine wildlife are caught as bycatch, with almost all being discarded. As target species increase in size, so too do the net mesh dimensions, allowing for smaller organisms and juveniles to evade capture. However, approximately 40% of total haulage weight for midwater trawling is made up of larger, non-target species subsequently thrown back into the sea. Bottom trawling is the most destructive of fishing operations, in most cases destroying benthic flora and fauna communities with non-target species accounting for up to 90% of the netted catch. One potential solution to overfishing is fish farming. 47% of seafood is currently derived from farmed fish, but some species require fish meal as a food source. For example, 5 kilograms of marine captured wild fish are needed to produce 1 kilogram of farm-reared salmon. Intensive fish farming operations release considerable quantities of organic effluents and disease treatment chemicals into the marine environment. Fish farm waste not only affects surrounding waters but can also disturb a wider coastal area at different ecosystem levels, generally resulting in reduced biodiversity due to the imbalanced inputs. The crowded and stressful environments in fish farming provide ideal conditions for formation and transmission of various diseases and parasites. To combat the loss of investment from disease, farmed fish are generally treated with large quantities of antibiotics in their feed. As a result, wild fish that come into contact with fish farms are susceptible to contracting diseases and parasites they have not previously encountered. Removing meat and fish from the equation is not necessarily the answer. The processing stages of vegetarian foods require considerable energy inputs, such processes including heating, drying, cooling, and freezing. Additional environmental burdens result from a variety of activities. These include air or ship transport and the associated need to deep freeze, particularly with exotic foods, massive pesticide and herbicide applications creating ecotoxicological problems, nitrate and phosphate fertilizers disrupting the global nitrogen and phosphorus cycles, leading to eutrophication and threatening biodiversity, with nitrogen pollution in particular considered to be in the top 3 threats to biodiversity. Deforestation, in order to expand the area of arable land, is a globally occurring issue, as is monocropping, which is leading to decreased biodiversity. Soil erosion, with 10 million hectares of cropland lost a year, and greenhouse cultivation carries a large environmental footprint. Soy is a popular vegetarian substitute as well as a key component of livestock feed. Global conversion to vegetarianism would greatly increase the demand for soy. Soy is cultivated on a massive scale in South America, in particular in Brazil, where soy plantations are rapidly expanding into the Amazon, requiring mass herbicide and pesticide application, ever-increasing uncontrolled GM crops, and monoculture. Animal and human drinking water is severely polluted from the vast quantities of herbicides released into the environment. A soybean from Brazil will travel overland by lorry from, for example, the Cerrado in central Brazil to the soy port of Santarém, where it journeys 10,000 kilometers by sea to a port such as Amsterdam and a further 600 kilometers to a major port on the South English coast, producing considerable emissions. Only 31% of land is suitable for crop farming, against the 64% suitable for livestock. Ridding the world of ruminant livestock would not only make environmentally friendly crop rotation difficult, but would mean the loss of a globally important fertilizer. Greenhouse cultivation in unsuitable climates is a way to increase food production, but it is incredibly energy hungry due to the use of short-life plastic, misting, heating, and lighting. 74% of UK agricultural total energy use is as a result of protected cropping, which also accounts for around a third of UK agricultural carbon dioxide contributions. In conclusion, estimates of halting climate change by 2050, categorized as stabilizing carbon dioxide at 450 parts per million, will cost $40 trillion. A substantial decrease in meat consumption between 2010 and 2030 could decrease this cost by 50% to 80%. Options for reducing the footprint of the meat sector include decreased consumption of red meat and greater consumption of chicken as a low land use alternative and optimizing feed composition with high nutritional value and low land requirements. Regarding the fish industry, use of bivalves such as mussels, which filter feed, remove nitrogen and phosphorus from the water, and farming omnivorous species such as carp reduces the requirement for fish meal in comparison to carnivorous farm species such as salmon. Flexitarianism, or part-time vegetarianism, is another way to decrease meat and fish consumption, or converting to organic local meat and vegetables and locally caught fish. Although this reduces yields, it leads to better soil quality and increased biodiversity. Protein replacement, for example using worms or insects for burger meat, has also been considered, in addition to lab-grown meat. Aquaponics is a closed-circuit, self-sustaining cultivation system, but hasn't yet been tested on a commercial scale. And finally, reallocation of some feed crops to people would provide more food, particularly to developing countries. The answer is not clear-cut. However, choosing sustainable dietary options is necessary to reduce the environmental impacts that have been discussed.